Homework 19, we're going to solve log equations now. You'll see two different types. You'll see this one here. Notice all of them have logs. Same log base 3s. Log base 3, log base 3, log base 3. This one here, we have a combination of logs and not. Ones that don't have them. Right here, log base 3, and this one doesn't have it. Okay, so these two are worked differently. We are going to work with this first and then we'll go to this kind. And neither one are difficult. Okay, but the thing you have to do is you must check all of your solutions, okay? Because sometimes you're going to do all your math right, and when you check it, it's going to give you an error message because the solution isn't in the domain. Okay, so here's the first method. Solve round answers to the nearest hundredth. I'm going to give you exact answers and then I'm going to give you the rounding answer. Okay, you will be asked both from me. Okay, when we have the same bases and these two sides are equal, remember these are exponents. That means they both have to equal to give us this argument. Okay, so what we're going to do is we are going to, when you have it written like this implies that when you have the same bases, your arguments have to equal each other. So we can set 5x minus 1 equal to the 2x plus 14 here, okay? And that is because of this equivalence property of log expressions. Okay, it says if you have these two things where the bases are the same, the arguments are going to be the same. Because remember, their exponents are the same. All right, so we're going to solve. This is old stuff. Subtract 2x, and we get 3x minus 1 equals 14. We are going to add 1 to both sides, and we're going to get 3x equals 15. Divide by 3, and we get x is equal to 5. Okay, what you need to do is check. The main thing you're checking for is this going to, in our domain, it can't be negative, it can't be 0. So when you go to check to plug this in, make sure it's positive. Okay, so let's just check right here. Now again, we can let our calculator do this, but I'm going to go log base 2 of 5 times 5 minus 1 should be log base 2 of 2 times 5 plus 14. So over here you get log base 2 of 25 minus 1 gives us 24. Over here you get log base 2 times 5 is 10 plus 14 is 24. I think, I don't know if I said 24 here or not. Okay, now you can tell the left equals the right, but that's not really the reason. I mean, it is, but you can't go by that. Can you take log base 2 of 24? Yes, if you do this on your calculator. Okay, let's find that log base thing button. Base 2 of 24. It's going to give you it's not going to give you an error message. Okay, now just a reminder, if you don't have that button, you're going to say natural log or log of 24 divided by, or you use your fraction key, either way. If you use division, make sure you close that off, because if you don't, it's going to give you some funky number. Okay, then, or a different answer. Log base 2. Remember, base goes on the bottom. You rather do that, or you do your fraction key, which I'm really bad about doing. I don't really do that. I'll do the natural log of 24 over the natural log of 2, because again, the base goes on the bottom. Okay, now when we work this over here, again, same logs. You've got single logs on both sides, so this little double arrow stands for this implies x minus 7 is equal to 5 minus x. Now you're just going to solve. I'm going to add x to both sides. You get 2x minus 7 equals 5. Right here, you're going to add 7. You get 2x equals 12. Divide by 2, and x equals 6. Okay, all the math looks right. So let's go to check it. When you check it, you're going to go log of 6 minus 7. So you get the log of negative 1. And then you're going to get over here log of 5 minus 6, which gives you log of negative 1. Yes, the left and the right came out to be the same log, but this is going to give you an error message on your calculator because there is nothing that I can raise 10 to that's going to give me a negative number. Log of negative 1, when you do that on your calculator, it gives you an error message. So the main thing you're looking for is that these are not negative. Our arguments are not negative. So you got to kick that answer out, and in this case there's no other answer, so our answer here is no solution. May or no real solutions. Okay, I don't really care which one you put. All right. We can't set our arguments equal to each other like we did here until you use your condensing properties. Right here, we need to get this left-hand side down to a single logarithm before we can set our arguments equal to each other. So in this case, subtraction goes with division. So we're going to have log base 3 of 3x minus 4 on the top, because it is positive, this is negative, or subtraction, it goes on the bottom. X plus 1 goes on the bottom, equals the log of log base 3 of 2. Okay. Now we have single logs on both sides. Now you can set your logs, your arguments equal to each other. I have 3x minus 4 over x plus 1 is equal to 2. I don't want to work with fractions, I want to get rid of them. So to do that, I multiply both sides by x plus 1. That cancels. I'm left with 3x minus 4 is equal to, I'm going to go ahead and distribute this, and I get 2x plus 2. Now I'm going to solve. I'm going to subtract 2x from both sides. I get x minus 4 equals 2. Add 4, and I get x equals 6. I got to check it, and it doesn't matter where you check it. You can check it up here, okay? You can even check this on your calculator. Okay, if I do that, I'm going to store my 6 under my x. Okay, this is going to take a little bit. Log base 3 of 3x minus 4. Now I wouldn't do this. I personally would just take my 6 and plug it in here. And I would get log base 3 of 18 minus 4 gives me 14. Okay, minus the log base 3 of 6 plus 1 is 7. Okay, and see, I know my rules for my properties of logarithms. I have subtraction, so I can divide that, and I get log base 3 of 14 minus divided by 7 is minus goes with division, which is log base 3 of 2. And that's what I had on that right side. But I know you guys would probably feel more comfortable checking it on your calculator. So minus x plus 1. Okay, so when I do that, my left side gives me that decimal. My right side is going to give me, hopefully, the same decimal. And it does. So the left equal the right. The main thing I'm looking for is to make sure when we plug our numbers back in, that this gives me a positive number, that it doesn't give me 0 and it doesn't give me a negative, because then I got to kick it out. All right, right here I have addition. I got to make sure, I got to get this into a single log. Multiplication, addition goes with multiplication, so I have the natural log of x plus 3 times my x equals the natural log of 10. Now I can set my arguments equal to each other. I'm going to go ahead and distribute. Get x squared plus 3x on that left side. And I have 10 on the right side. Well, we've been doing this since the beginning of the semester. You've got to get it set equal to 0. So I'm going to subtract 10 from both sides. And I get x squared plus 3x minus 10 is equal to 0. At this time, if you want, you can use quadratic formula. I'm not. The negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm not because it factors. Factors as x plus 5, x minus 2 equals 0. So if I set this equal to 0, I'm going to find that my x is equal to negative 5 here and a positive 2 here. If you don't know how to do that, set each of these equal to 0 and solve. Now I got to check both of them. Now I know I'm going to kick out this negative 5 because if I plug this in right here, either way, and when I check that negative 5, this one right here gives it away. Natural log of negative 5, I can't do it. Okay, but even if you plugged it in here, you'd get negative 5 plus 3, okay, plus the natural log of negative 5, all right, equals that natural log of 10. I'm running out of room over here, okay, but this gives us a natural log of negative 2. That's going to give me an error message. Natural log of negative 5. That's going to give me an error message. Okay, so that we're going to kick it out. Even if I use my rules for exponents and I multiply, yes, that gives me a positive 10, which equals the right side, but I'm not, it's not in the domain because of that. So we're going to kick that 5 out. And now we're going to check the 2. I'll just check it down here where I have a little bit more room. And I'm just going to kind of skip this a little bit. I'm going to have the natural log. When I plug in 2 right here, I'm going to get 5. 2 plus 3 is 5. Plus the natural log. And when I plug in 2 here, I get the natural log of 2. And I know with addition goes multiplication, so I am going to get the natural log of 10 on this side equals the natural log of 10 on this side. Now the same thing I'd get up here, but I can't do this part in order to do the multiplication part. But you can even check these, all right? Again, I'm looking for when, the main thing I'm looking for is when I plug this in, that it gives me a positive number. But if I took 2 and stored it under x, and then I did the natural log of x plus 3 plus the natural log of x, I'm going to get that number there. Whoops. Let me see something. Because see how I have a double parenthesis here? Sometimes that's going to screw it up. I think that will. Yeah. See, don't take that one. Be real careful. That's why you got to be careful. I always forget it starts with a parenthesis. Okay, so this now looks like that. Now, the natural log of 10, and that gives me the same thing. Don't do that. Don't put that, because what that's doing is it's finding that and then taking the natural log. Okay, if I had tried the negative 5, store x, and I brought this back up, because that's what that says right there. Remember, it doesn't say this, it says this. It's going to give me an error message. Okay? All right, so my answer here is just x equals 2. And I think I got one more problem. Oops, not there. Using the same type. Okay. So what we have to do is use all our condensing properties. okay, before we can change, set our arguments equal to each other. So what I'm going to do, let's take this, get it so that we don't have a coefficient. So on this side, we're going to have log base 3 of x squared. Over here, we're going to take log base 3, and because it's addition, we're going to multiply. 2 times the 3x minus 4. Now that we have single logs on both sides, this implies that our arguments are the same. So we're going to take our x squared, set it equal to this argument, but I'm going to go ahead and distribute that because I know I'm going to have to solve. 2 times 3x is 6x, 2 times negative 4 is negative 8. I got to get everything to one side so that I can factor or use quadratic formula. I'm going to take this over there by subtracting it. I'll take this negative 8 over here by adding it. So now I have 0 on that right side. Over here on the left side, I have x squared minus 6x plus 8. This will factor x minus 4 and x minus 2. My x here is going to equal 4. My x here is going to equal 2. Okay, I got to check it. If I plug in 4 here, that's fine. If I plug in 4 here, 3 times 4 is 12, minus 4 gives me 10. That looks good. Now, in your calculator, you can do that if you want. I'm just going to plug it in here. I'm going to get log base 3 because it doesn't matter. These are the equivalent. They're equivalent. So log base 3 of 4 to the second power, that gives me 16. Okay. Over here, I can do I can plug it in here or here. It doesn't really matter. Seeing I'm plugging in here, I'll plug it in here. So I have 2 times 3 times 4 minus 4. Okay. So right here, I'm going to have log base 3 of 16. Over here, I'm going to have log base 3 of, this gives me 12, minus 4 gives me 8. Okay, 2 times 8 is 16. The left equals the right. Now again, you can check it on your calculator. And now let's do the same thing for the 2. So the 4 checked out. Let's do the 2. That's going to give us the log base 3 of 2 to the second power, gives me 4. If I plug in 2 right here, this gives me 6 minus 4 gives me 2. 2 times 2 is 4. So again, the 2 checked as well. All right, so both of these are our answers. Now, I want to go back just for a second for the last problem that I just worked, if I can find it, because some people think that when you work them all out, that this answer, can't be negative. It's fine if this is negative as long as when you plug it back into whatever you're plugging it into is not negative. Okay, like here, if this answer had been a negative 5, over here would have been fine, because 5 minus a negative 5 gives me 10, but it wouldn't be over here because I'd still end up with a negative 12. I didn't really, but just know that we didn't kick this out because my answer turned out to be negative. We kicked it out because when we plugged it in, I can't take the logarithm of a negative number here, and I can't take a logarithm of a negative number here. So, okay, I'll do the other kind in another video.